JEE Advanced 2025, Paper 2, Physics, Question 15. Let us visualize the setup. A projectile of mass 200 grams is launched at 60 degrees to the horizontal with an initial velocity of 270 meters per second in a viscous medium. The projectile experiences a drag force proportional to its velocity, opposing the motion. After 2 seconds, it hits a vertical wall. We need to find the horizontal distance to the wall. Let me keep this diagram in the corner for reference. Here is the question. A projectile of mass 200 grams is launched in a viscous medium at an angle of 60 degrees with the horizontal, with an initial velocity of 270 meters per second. It experiences a viscous drag force F equals minus C times V, where the drag coefficient C is 0.1 kilograms per second, and V is the instantaneous velocity. The projectile hits a vertical wall after 2 seconds. Taking E equals to 0.7, find the horizontal distance of the wall from the point of projection in meters. The key concept here is motion with linear drag. When a drag force is proportional to velocity, the equation of motion becomes a first-order linear ode. The velocity decays exponentially with time. To find displacement, we integrate this exponentially decaying velocity over time. Crucially, in the horizontal direction, there is no gravity, so only drag acts. This makes the horizontal component fully solvable independently. Let us solve this step by step. First, let us list the given values. Mass m is 0.2 kilograms, launch angle theta is 60 degrees, initial velocity v0 is 270 meters per second, drag coefficient c is 0.1 kilograms per second, and time t is 2 seconds. The initial horizontal velocity is v0 times cosine 60, which equals 270 times 1/2, giving us 135 meters per second. In the horizontal direction, only the drag force acts. Newton's second law gives m times dvx by dt equals minus c times vx, separating variables, dvx over vx equals minus c over m times dt, which is minus 0.5 dt. Integrating both sides, we get vx of t equals 135 times e to the power minus 0.5 t. Notice how the horizontal velocity decays exponentially. At time 0, it is 135 meters per second, and it decreases as e to the minus 0.5 t. This exponential decay is the hallmark of linear drag problems. Now we integrate the velocity to get horizontal displacement. X equals the integral from 0 to 2 of 135 e to the minus 0.5 t dt. The integral of e to the minus 0.5 t is minus 2 e to the minus 0.5 t. So x equals 135 times minus 2 e to the minus 0.5 t, evaluated from 0 to 2. This gives us 270 times the quantity 1 minus e to the minus 1. Now we substitute e equals to 0.7 as given. X equals 270 times 1 minus 1 over 2.7, which is 270 times 1.7 over 2.7. Simplifying, 1.7 over 2.7 equals 17 over 27. So x equals 270 times 17 over 27, which simplifies to 10 times 17, giving us 170 meters. The answer is approximately 170 meters, which falls within the accepted range of 167 to 171. The key was recognizing that horizontal motion with linear drag leads to an exponentially decaying velocity, and integrating this gives the displacement formula involving 1 minus e to the minus c over m times t. Here are some important tips for JEE Advanced. First, for linear drag problems, always separate horizontal and vertical components. Horizontal motion with drag alone gives a clean exponential decay. Second, the general displacement formula with linear drag is mv0 over c times 1 minus e to the minus c over m times t. Memorize this result. Third, when the problem says take e equals to 0.7, it is hinting at simplification. Always look for clean cancellations like 270 divided by 27 equals 10. Fourth, remember that vertical motion with both gravity and drag is more complex, but this question only asks for horizontal distance, so you do not need it. If you found this helpful, like and subscribe for more JEE Advanced solutions at MAGPIEHUB. See you in the next one.